Morning, everybody. Obviously, I am here. Today's class is going to end about 10:30 because my surgery appointment is 11:15. So I'm like literally leaving this room, uploading the video, and my wife's picking me up right there, and we're boom, right, to get there as fast as possible, which is why they told me to wear comfortable clothing, so I am. So that's what's going on here. So we're going to cut today just a little bit short, but this actually works out really well. It'll keep us on the schedule of our exams, which is technically better for you. You just have to trust me on that one, because if we push this exam back and then we start it really just kind of builds on us till the end of the semester. So no, it's really bad. So. We're actually going to be right on schedule. I know the schedule feels so fast, and it is, right? And so what I want to do today, technically I had one more example to do for you in chapter 3, but we don't really need to do it. What I think we should do instead is talk about exams, give you the kind of deep details on what you can expect this Thursday. And then I want to help you on some chapter 3 homework, because I've noticed not a lot of people have gotten started on it, right? And when's it due? Tomorrow, right? Okay. And we got a lab to do tomorrow. Bring goggles to the lab tomorrow if you want your own personal pair. Otherwise, you'll be forced to wear one of our pairs, which are sterile, just not necessarily clean. So anyway, let's talk about kind of what you can expect. On Canvas, there is a sample exam, okay? It's under the modules, okay? If you go down in module 1, it's at the very bottom of module 1, and you'll see I know you're other teachers have given you practice tests or something. It's not that. This is my way of showing you the kinds of questions you can encounter on one of my exams and sort of the expectations that I have for you in answering them. What does that look like? All that kind of stuff. It does contain the title page, the exact same title page you'll see tomorrow, Thursday, okay? So that you can read this ahead of time without having to read it when you come in, right? I want you to be able to come in, put your name on it, sign the honor pledge, and away you go, okay? There is going to be this honor pledge. It's in my syllabus. It says that I pledge that I have not received any unauthorized assistance, given or received any unauthorized assistance on this exam. So let's talk about, just real quick, unauthorized, and you're going to write that on the front of the exam and sign it. If you have any trouble doing that, you need to let me know ahead of time. What is unauthorized assistance? Can you make any guesses?
Tattooing the answer key to your wrist.
Okay, so tattoos that have all the answers. Okay, so instead of having to tattoo yourself, where are you allowed to put equations and things? Your cheat sheet. So is your cheat sheet authorized? Yes, absolutely, right? So whatever you want to, and we'll talk about the cheat sheet in a little bit, right? So that's totally authorized, okay? What's unauthorized? Yeah, looking at somebody else's cheat sheet would be unauthorized assistance, okay? And that extends to looking at somebody else's test sitting right next to you, right? That would also be unauthorized assistance. Using your phone, authorized or not? Unauthorized, right? So I don't really I don't try to sit here and judge whether or not you are cheating, okay? If you're doing right, we're going to have a conversation, okay? But if I see anything that is unauthorized, I will just come up to you and say, that's unauthorized, and you're now done with your exam. I'm just saying you're finished, right? Okay? We can talk later, okay, about what's going down, but I'm inviting you to leave at that point, so we're not disturbing anybody else, okay? So if an unauthorized, technology's out, you've got your wristwatch on, any of that kind of stuff, earbuds in your ear, I'll just say, that's unauthorized, you're done, you're finished with your exam now, okay? And I'll invite you to leave and we'll talk about it later. So So that's kind of like my policy, right? It's pretty, I think it's kind of clear and cut and dry, right? And you can read on this front title page, okay? Kind of what's unauthorized and not. Some of you might have questions like, Mr. Balogh, I need a foreign language dictionary, right? English is not my primary language, something like that. Ask me ahead of time, right? Not like the day or the moment the exam's happening, but like ask me ahead of time, hey, Mr. Balogh, can I use this? Can I use that? All that sort of stuff. Some people are like, well, Mr. Balogh, I can program my calculator to do whatever. Like, you know what? If you're going that deep into your calculator, maybe you deserve to be able to use it. I don't know, right? Like it's just, you don't really want to waste time on exams. So again, any questions about what's authorized or not, please ask me, right? Have that discussion. I'll set you straight, and we'll all be good. I'll hand out the exams at the beginning, right at 9:30, okay? The exams will be 2 colors because there's 2 different versions of the exam, okay? And it's important that you not have the same color as a person sitting next to you, right? So we're going to have this fun game where we're going to see if you guys can actually pass out papers in order, right? Because I'll have them like all set and ready to go, and I'll put them at the ends, and people will just pass them down, okay? The other thing we'll do is we will make sure that every chair gets an exam, not just every person, right? So I'll have an exam for every space in the room, right? And so as you're passing them out, if there's a gap, just put, the correct color, right? And it's, we want to do, colors one after the other, so that you're sitting next to somebody who has a different color than you. That's how you'll know that you'll be safe from any wandering eyes, because if they try to look, it's not going to help them. All right. The kinds of questions you can expect on an exam. I consider that there's like kind of 2 broad categories of questions. There are what I consider to be computational problems, where you're using like our physics problem solving method. You got to do some math and some concept, like there's that homework, okay? And then there is the conceptual type of problem, okay, where you don't necessarily have to use math to be able to answer it. You're explaining more your thought process. I've been trying to train you on these conceptual questions in your homework. You've been given them. And then we have like our quizzes that we do together in class, right? So this has all been sort of training for this type of question. The way that you know the difference, okay, is that a conceptual question has multiple guess parts to it, okay? All the other questions on the exam, okay, have a question and then a blank area, right, in which to do it. Now, it's 2 questions per page. There's 7 questions, so that means the last page will have 1 question on it. The back side of every page is blank, okay? And I put 2 blank pages in at the end of the exam. So there should be enough room, plenty of room, for you to be able to do your work right on the page. And if you start running out of, like, say, the room below, like the half sheet for that question, right, you can just put a little note that says, see page, 6. Right? And then, you can keep working there. You can take the staple out of your test, but you do kind of have to like sort of contain it to your little area, right, on the desk. Can't start like spreading it out, all that kind of stuff, right? So you have to work tight, and you have to work close, and you have to work fast, but you'll be working, right? And you can see here, right, there's this question. I'm not saying, this isn't reflective of like the difficulty or anything, but you can see here, right, I'm really only asking you one thing, right? How fast was it going when it was thrown, right? That's the question this was asking, okay? You're given some information. This one actually has a diagram, right? And you can see here that I am trying to communicate, right, that I can set up the problem and do it. Again, don't freak out on like, I don't understand Mr. Balogh's way of doing anything. It doesn't work for me. I can read physics in any form, right? And I can figure out by looking at what's going on the page, what's in your brain pretty well. Not 100%, but I can do it pretty well. So I'm less worried about sort of how you're doing the problem, as in, what are you communicating to me? about what you have learned, right? So I think that more information is better, right? The more you put down. If you do something wrong, I would say don't erase it. Just draw a line through it and then, start, just don't take time to sit there and erase and all that kind of stuff, right? Because maybe you were on the right track and maybe I can give you a little bit of credit for being on the right track the first time, even if you got thrown off the second time, right? So like, show me, just show me, okay, what you got. And I'm doing it in sort of my method here, right? But the bottom line is show me as best you can kind of what you're doing. Show as much as your work as you can, okay? And then when you get an answer, box it, okay? This is how, like, I waste a lot of time because there's so many numbers on a page sometimes that I'm not sure kind of where you're going, right? And so a box is a nice anchor for me to say, okay, this is what they got. Okay, how did they get there? And I can kind of follow it backwards or forwards or do whatever it is analysis I need to do, right? So if you get an answer, just box it, right? It's kind of like committing, so like pushing the button on Wiley Plus, right? Only it's not going to turn green or red, right? It's just going to be what it's going to be, right? So if you wouldn't mind, I'm not going to like grade it wrong if you don't box it. But trust me, you don't want me angry while I'm grading. Where's the box? Where's the box? Right? Okay. So anything you can do to kind of help communicate like a step that you're taking or something like that. Again, I don't want you wasting time being totally verbose, but like, draw an arrow somewhere, right? Like, and this is what's going in here. Whatever way you can do it. If I can't figure it out, I'll ask you about it. Okay. So there's that example, right? And then conceptual questions tend to freak students out a lot. And I get a lot of questions during the exam. Well, Mr. Balogh, I don't know how to prove it, or I don't know how to answer this question. I know this answer is right, but I don't know how to explain it. My answer to that always is, then tell me why the other choices are wrong, right? Like, usually it's easier to say why something's incorrect than to say why it's correct. A lot of times it's correct because, and the answer would be because physics says so, right? But like, that's not enough of an explanation. So show me why the others are wrong. It's a really great way to go about doing that, okay? Sometimes you can't eliminate all of the choices. Sometimes you're like kind of going between two of them, right? So tell me why you've eliminated the ones you've eliminated, and then tell me if you're guessing, right? Like, okay, I got down to these two and I just guessed. If you got it right, you know what? I'd be like, hey, good job, right? So show me what you know, right? This one you can see that I made an explanation as to why this has to be. I even boxed this answer, but really circling it and then having some explanation. You can draw pictures for these, right? Whichever way you want to go about explaining what it is you know, okay? Do that. There's one conceptual question on your exam out of the 7. So 6 like computational, more homeworky style problems. And then there's a conceptual question on your exam. So questions about like format or what you can expect when you like walk in the room and all that kind of stuff. What can I answer that will help you be as least freaked out as possible? Yeah.
So just to confirm, for concept questions, you get 1 point for getting it right and 1 point for explaining.
Actually, right and wrong doesn't matter that much to me. What matters to me is your explanation of what you're doing. Now, granted, if you're totally wrong and you've got this wonderful explanation and you're just like totally wrong, then you're wrong, right? But so there's 7 questions and each question is actually worth 2 points. 2 points is you did it right, you got the right answer, good job, okay? And then 0 points is, yeah, you really didn't get any traction in this, okay? Sometimes I see a lot of math on the page and it's like you were trying to just throw pieces of pasta at the wall to see what sticks, right? And nothing was sticking, right? So like, I can kind of tell what's the state of a brain based on what's on the page right here, right? Do you know what you're doing? Do you understand the physics, or do you not, right? And so that's a 0. And then there's this kind of discretionary 1 point, okay? The middle number. And it's not necessarily a halfway point. I tend to, if you don't do the problem in full, I still tend to give it a 0. Like you kind of get halfway through the problem and then don't finish it or something. That's, again, this is very subjective at this point. But my kind of thing is that if you've got the physics 90% of the way there, then I'm kind of likely to like say, okay, that's worth a point. Okay. I tend not to worry too much about like, did you do the math right or wrong, right? You could do the problem completely correctly and have a different answer than me or a different answer from everybody else, right? And I can look at it and say, no, physics is set up really good here, and the number that you got for the answer is wrong, and I will probably look at that and give you 2 points. Because I can see the physics is right. You put in all the right data. You got the minus sign on whatever you needed minus. Like I can see that this is good, and maybe something just went wrong somewhere in the algebra, right? I don't want to go look for it. Okay? And so I'm going to give you the benefit of the doubt for having got the physics right. This isn't a math class. I'm not a math teacher, right? I might give you the 2 points. If I see that you set up the physics correctly, but then like screwed up the math, like made an algebra error, and I can see it right away and all that kind of stuff, like an obvious algebra error, I give you the 1 out of 2, because you do need to know both math and physics. Like there was a prerequisite for this class, right? But I tend to give full credit for when I think the calculator lied to you. And calculators lie most often when it comes to parentheses on things, right? So I make a judgment call right then and there when I'm grading it. Okay, does this look like an arithmetic error in a calculator kind of thing? Or did you do the quadratic wrong, right? Did you do some invalid algebra, got too excited about dividing by things or whatever, right? Okay. However, if you have a problem that's like a projectile launching and ends up lower and you don't put negative, right, on the height, that's like 0. And you'd be like, but Mr. Balogh, I did the rest of the problem correctly. I know, but you royally screwed up the physics. Like you tried to do a problem where the ball ended up higher than where, and right? So I'm really concentrating on your knowledge of physics. I kind of have your back when it comes to the math, right? Especially kind of trying to get your calculator to give you the right answer, right? And you know that frustration, don't you? Like with Wiley Plus and stuff, like trying to just, like I'm doing this right, but Wiley Plus, oh, this stupid parenthesized and the squared and whatever, right? So, yeah, the radians, that kind of thing. That'll come back and bite you later when we're doing circular motion, because then you have to know how to do it. But like, yeah, I've got your back as much as I can, and I'm really looking for correct physics, right? And like communicating to me that you have understanding of the problem and that sort of stuff. This frustrates students sometimes because they're like, well, Mr. Balogh, if you just give me the equation, I could have gotten a perfect score. I was like, well, yeah, but the whole point of physics is to figure out which model applies, which equation to use, all that kind of stuff. Did that answer your question? In a lot of ways, the first exam too is a little bit like kind of our third lab, right? It was like, okay, how do you get used to what this teacher expects, all that kind of stuff, right? The good news for you is that next week there will be an exam autopsy where we're going to have a chance to argue with each other, right? You'll have a chance to come up, Mr. Balogh, I did this right. Why did you take points away, right? And you'll have a chance, right? We'll work out together what's going down. So you'll learn a lot more there. Other questions, things you have to know, like just to make yourself feel good. Yeah. Oh, thank you. Malachi, you're wonderful. I forgot to do it for physics. We'll start at the front today and we'll work our way to the back. Let's talk Okay, so what should be on your person, like when you're sitting down to take the exam? What should you have? Something to write with, calculator, and your cheat sheet, right? Okay. No smartwatches, no earbuds. Your phone needs to be in some sort of, I prefer it to be off, but at least in like airplane, like where it can't get signal. Because what I don't like listening to is all the buzzing that goes on in the backpacks at the front of the room. Okay? Because I'll zzz, 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 right? Okay? So try to make it so that your phone is not receiving anything. And when you walk out and forget to turn it on and you have several hours of peace in your life, you can thank me later. You're going to put everything in your bag that's not something to write with in your cheat sheet, right? And your calculator. You put it in your backpack, and we're just going to line all the backpacks up here, okay? Any backpacks left over at the end of the exam, I will just auction off on eBay or something, okay? But we'll just put it all up here and then just go have a seat, right? And when 9:30 rolls around, we'll get started, okay? And I'll get the exams out to you. You'll have 5 minutes to write down the honor pledge and sort of center yourself, look over the exam, see which problems you think you might be able to do right away and which ones might take you a little bit longer. And then after that sort of initial 5 minutes, you'll have 70 minutes, right, to get it done. So about 75 minutes for the exam. What are you going to do when you're confused and have a question? Raise your hand? Of course you're going to raise your hand, right? Yeah. Sometimes students feel like they can't ask questions during an exam, especially because some teacher somewhere has probably made fun of you for doing it. Throw your hand up in the air and I'll come over and we'll try to have a whispered conversation to not bug the people around you. But please just ask, what's the worst thing I could say to you if you asked me a question? Yeah, laugh out loud in front of you. No, I'm not going to do that to you, okay? Not going to do that to you. The worst thing I could say is, I won't answer that question for you. That's the worst, because you probably you asked me something along the lines of, Mr. Balogh, how do I do physics? Right? And that's okay, but I'll just remind you that this is your turn now. Okay, you see, that's something that I can't answer because I got to keep it fair for everybody. But chances are I either screwed up on the question or something wasn't real clear, or maybe I forgot a conversion factor, whatever, right? If I think the whole class needs to know it, I'll go right up on the board with the conversion factors or something, right? Or this is very common. Sometimes questions come out of the test bank that are like very American-centric. They'll refer to like baseball or football rules or something. Maybe that's not something you're familiar with, right? And you need a different context in which to understand the question. So ask me. I'll reword it, okay? I don't know how cricket's played, but I'll try, right? Like it's just, I'll try to get it. What I'm more concerned about is you understanding what you're being asked to do, right? And then you showing me, right? What's going on. So please don't hesitate to ask. I am not going to think less of you for asking. I usually think more of people when they start asking questions. Some of you are like, oh good, I'm just gonna ask questions, right? Don't do that either. But you get the idea, right? But please don't hesitate to ask questions. If I can be politically incorrect for just a second. I know that there are people in this room that come from cultures where you are discouraged from questioning authority, right? For pointing out an error or even like asking a question in public or something like that. I promise I will not tell your mother or your grandmother, okay, that you asked a question, right? Like it's between you and me. They don't have to know, right? Please question. Please, please, please. I'm inviting you, right, to question me. And again, I know there's other teachers that are like, you will not talk to me. You will not. I'm right. You are wrong, right? I'm not that kind of teacher. So please just ask the question so we can make sure that you are working at your peak ability. Let's say you think you're done, right? You're all done. What do? Sit there in silence and just suffer? No, you will check your answers, right? Okay, but now you've checked your, right? And you're like, what? This is too fast. I just have done this all wrong. Deep breaths, right? Bring it up. I'll have a bin to turn them in. You're going to staple your cheat sheet to the back of your exam. Please don't panic. I am not grading your cheat sheets. The reason I want them to be there is that when I'm all done grading, I like to go back and look at your cheat sheets because it gives me a snapshot of what you as a student thought was important, right? This is more of a me keeping my finger on the pulse of what students' brains are doing in the current moment, right? I don't look at names or anything like that. I just kind of am looking at cheat sheets to get an idea of what, again, you thought was important, what you picked up from class, all that kind of stuff, what you distilled down. And if I see like there's holes or things, then as a teacher, I might sit back and go, okay, what did I screw up on, right, in communication or something like that. So that's more for me to just kind of get feedback on where your brains are at in terms of the communication, the transmission of information that's going on in class, and less to do with the actual physics and what's in your brain. Shall we talk about cheat sheet a little bit?
Yes.
What's some things you want to put in a cheat sheet? Yeah, equations that you feel are important. You have run across them in your homework on problems, right? I've tried to show you that there's really only 3 equations from chapter 2 that are necessary and 3.5 from chapter 3, like the little x equation, right? But I will not give you an equation. You can say, Mr. Balogh, can you give me the second kinematic equation? I'll be like, no, right? You need to put in some effort into thinking about like what possible things could you want to refer to on your cheat sheet. For me, I made a cheat sheet for every exam that I took in college. And even if the professor didn't let us have a cheat sheet, I made a cheat sheet anyway. I did not cheat. I want to be very clear here, okay? But I made the cheat sheet anyway. And right before the exam, I would pull out the cheat sheet and I would like, you know I'm terrible at memorization. I would try to remember as much as I could, all the equations, whatever, right? Definitions. And then I'd run into the exam, I'd grab the exam, I'd turn it to a blank page, and I'd start writing as much of that cheat sheet as I could remember, okay? The reason being is that when I finally started thinking about the problems or whatever was being asked, I have bad test anxiety, I would start freaking out, I'd do all these different things, right? Convincing me that whatever, I'm doing it wrong, I'm gonna die, I better become an English major, whatever, right? Spiraling down. And the cheat sheet, even the one that I just copied from my memory, was like a safety blanket. It was like a way, because I couldn't remember the equation, I didn't remember, is it V first or V naught or whatever? I could just flip it out. Oh yeah, that's what the equation is. Half the time it was wrong because it came out of my memory. It was wrong anyway. But like, at least I had a kind of a calming, it was like a little friend there with me, right? Something just to refer to and get my mental juices going on what the problem could be. So that's what I want the cheat sheet to be for you, right? This is why I don't give you one. I'm asking you to make one. And some of you will be like, oh, I'm just going to copy my friends. Okay, that's fine. I'm not going to dock points or say you did it wrong or anything like that. But you're really robbing yourself of like this time to summarize the information that you've been learning, get it into one place, right? You do not have to put on your cheat sheet any conversion factors. If it's a conversion factor, I will give it to you. If you want to know how many meters there are in a foot, I'll give it to you. Unless you're asking me to just give you the answer to the conversion factor problem, right? Okay. But on exams, I put conversion factors down, okay? Right on the exam, right in the problem, the ones that either I want you to use or I think you might need to use. If you want a different conversion factor, just come and ask. Again, worst thing I'll say is, well, the problem's really asking you to figure that out, right? But that's only really for chapter 1 problem. All other parts, you can just ask me for conversion factor and I'll give it to you. You should know kilo, milli, micro, nano, like some of the prefixes, and we talked about that a little bit in class. First exam, if you ask me, what does kilo mean, Mr. Balogh? I usually take that to mean, Mr. Balogh, I am totally freaking out and I can't remember anything. You know that moment in a test where like it seems like the amnesia generators that we install on the walls have been turned on high. And you come in, you sit down, you look at the question, your mind just goes blank, right? Sometimes just putting your hand up in the air and say, Mr. Balogh, what does kilo mean, right? I'll just say it's 10 to the 3. And then all of a sudden your brain will go, oh, that's right, right? And then you'll click it back in. As the semester goes on, I expect you to start knowing those things, right? So you might want to put those on your cheat sheet just to start getting used to what is kilo, what's a mega, what's a giga, what's a nano, what's a milli. In Physics 2A, really, kilo and centi are the two that we use most often. Sometimes milli. But in 2B, it becomes a lot more important. Can you put homework problems on your cheat sheet? Yeah. Can you put lecture slides on your cheat sheet? Yeah, I mean, this is yours. It's not mine. Okay? So put what you want on it. Okay? Piece of advice. If you are cramming in very tiny writing every possible note, everything you took for last year, that's usually the symptom of an unprepared mind. Right? Okay? I've noticed kind of an inverse correlation between the amount of stuff on a cheat sheet and score on the exams. Like the more concentrated information on a cheat sheet, the worse somebody does in the exam, right? Because you don't have time on 10 minutes per problem in a 75-minute exam. You don't have time to be learning how to do it. You got to show me what you know, okay? Some of you are sitting there, sweet, I'm not going to bring a cheat sheet. I'm going to get 100%. That's not what I mean, right? But there is some optimum amount of information to have on a cheat sheet for your brain, right? Where you can refer to something to help jog a memory or remember an equation or something like that, right? Versus having everything shoved on there and having a hard time finding what it is you're looking for, that kind of stuff. So again, it's your sheet. You should be the one, because it's your brain that it's coming from. Yeah. No, both sides. Technically the edges, but you're not allowed any technology to read that. So, but yeah, double-sided. You should. I'm hoping with one sheet back and forth, you will have plenty of room, because like literally, my cheat sheet would just have 3 equations on it, right? I understand yours might want to have more, right? But
I'm extrapolating, but I'm assuming they're also cool with them being tight.
yeah, I don't care if they're done on the computer or your iPad. I don't care. You just can't have your iPad or your computer with you during the exam, right? So at some point, it does need to be printed out on a physical piece of paper. How are you like feeling about this exam coming up, like based on what we've talked about today? Sort of the format or anything? Yeah, right. I know a lot of you are like really worried because you feel like you don't know anything or you haven't started chapter 3 homework yet and things like that, right? Those are, students will procrastinate as far as they can, all that kind of stuff. But the moment of your procrastination has come, right? You got a lot of work to do in the next 48 hours before we do the exam, including like the lab tomorrow and all that kind of stuff. So I think let's do a little bit of homework, and I might circle back to something else to help prepare your brains, right? But let's talk just a little bit about chapter 3 homework since it's due tomorrow. Okay, you can see all that, right? All right. Let's go to questions. These are all multiple guess. Okay. Okay. So it zooms in when I look at it. Okay. So reading it together, Are there any words that jump out to you that are like important? Let's not talk about numbers just yet, but like words, things that are like key to this problem. Horizontally. When you read that word, what does that mean? The initial, like what's the launch angle or what's the initial direction? It's perfectly along the x-axis, right? So what is the initial y velocity in this problem? It's 0. Good, see? You know some stuff, right? However way you have of visualizing, do that, right? Write that in sort of information down, okay? It said speed, right? So that's like just a number, but they told us horizontally that's the direction. It's like a launch angle of 0, right? Okay. And then they use the word horizontal again. This 20.5 meters. Of all of the symbols we could have from our toolbox, what does the 20.5 meters correspond to? It's like x, right? It's that horizontal distance. It's a two-dimensional problem, right? So 20.5 meters is an x. And if we want to, now they're asking how far above the court is the tennis ball when it leaves the racket. What are they asking for? Like what symbol, what idea? A y distance, right? So look for a strategy that involves delta x, this initial x speed. There might be something else you have to find there. What is it? Time. Time's the only other thing on that equation, right? And then see if you can't use that time to solve for a y. Being very careful about what your initial y is. You'll probably get a negative answer for y. And if you type a negative answer in here, I bet you it'll turn red. Because the question asks for what? How far above the court, right? We asked the question, okay, like how far did the ball drop, right? That's kind of what the kinematic equations will tell us. So we'll get a negative sign because it does drop, right? It ends up lower. So if you get negative 6.8, okay, then the answer Wiley Plus probably wants is 6.8. It tends to be a little bit literal that way. Okay. You're given an angle in this problem. What do you think you might have to do? More specifically than trig. Trig will be a part of it. You're given a magnitude and a direction. What is that? That's a vector, right? But this isn't like a vector problem from chapter 1. This is using vectors to find the initial x velocity and the initial y velocity so that you can use the right equations in the projectile motion thing. It says the golfer hits a shot from where they hit it to the green is 2.8 meters higher. So your y, is that positive or negative? Good, positive, okay. The speed 18.7 at 41 degrees, you're gonna have to break up those vector components, okay. And then find, oh gosh, this is tricky. Find the speed of the ball. What are they asking for? Is it v final y? No. Is it v final x? No. It's the magnitude, right, of those two components. And I did that on the last example I did on Thursday, okay? So you're going to find v final y. You're going to know v final x because it's the same as v initial x. And then you have to use a Pythagorean theorem to put those two components back together. They asked for speed, not vertical speed, not horizontal speed. They just asked for the speed of the ball when it lands, which is the vector, full vector magnitude. Again, angle, speed, right? So what are you going to have to do? Vector components, right? 10.4 meter high wall, what's that? X or Y? That's Y, and is it positive or negative? Positive. It's going up higher, right? And the 15 meters, that's the X. Okay. Now, this third sentence here, the rocket attains its launch speed in a negligibly short, I can't say that word. Negligibly? Is that even a word? What's negligible mean? Doesn't matter. Because it's so small, it doesn't matter. Okay. Short period of time. What they're trying to tell you in that sentence is that this is a projectile. Okay. They're telling you don't worry about the rocket's motor doing something, because that would not be free fall, right? Because that would be the motor pushing on it. So we assume that the motor accelerates it so quick that it leaves as a projectile at 68 meters per second at 46 degrees, after which it's in free fall. So we're good to go. They want to know, do they want to know why? Like the delta y, the vertical distance? By how much does the rocket clear the top of the wall? Let's say that you solve for the y position of the rocket at some certain time, right? And let's say you get 15 meters as an answer, okay? And the wall is 10 meters tall. What answer do you put in the box here? 5. They want the difference, right? Between what you calculate what the vertical position of the rocket is and what the wall actually is doing. I know I'm going really fast here, right? Especially if you haven't seen any of these yet. You're like, "Ooh!" You go back, play it back, see if it can help you a little bit, okay? You're like, Mr. Balogh, ChatGPT can do it better. Fine, do ChatGPT. Okay. Again, angle, speed, got to break up the components. What's the 25 meters? It's like X, right? What is Y for this problem? What's the vertical displacement for this problem?
The distance, the height difference between the ground and the soccer ball.
Yeah, do they tell us anything about that? No. So we assume a Y of 0. This is same elevation, meaning that it was kicked from the ground and implied caught from the ground. It's not like the goalie caught it, 2 meters above the ground or something, right? Okay. So Y is equal to 0 here, which sometimes throws off your calculations. So in situations where you got we did the building problem where the person threw the ball up, right, and it was coming back down. We kind of broke up the parts and we asked what's the speed as it comes back down or something. You guys learned that if it's same elevation, you can do half of the problem, right? What do we know about the vertical velocity of the soccer ball at the top? It's 0. Is its velocity 0? No, because it's still moving sideways. But its vertical component of velocity is 0. That's max height. So you can solve that time or whatever, and right? You can break it up to try, because sometimes a 0y can throw off some equations. Oh, that was it. Oh, good for that. Okay. And then I'll let you struggle through the conceptual questions on your own. Questions? Anybody that's been working the homework, you've been getting stuck, anything specific you want to ask about the questions? Oh, did we not go to? Oh, we weren't done. What happened? My thing blanked out. Sorry. We didn't get to the dolphins trouble. Angle. Yeah, okay, we've talked about this. It's the same kind of problem with almost the soccer ball problem that we just did. Okay, this problem is mean. This problem, it is the dolphin. And it's mean because of the way that they worded the problem. I actually had to go and this and do this. Paste. Sorry. Can't talk and cut and paste at the same time. Okay. There we go. Now I can draw it. So it's mean because of how they didn't tell us something. They weren't really clear about something. I actually had to go look and see how they did this problem to get it right, because like it was so badly worded, or at least for my brain, okay? So they tell us that a dolphin can jump straight out of the water, right? It says straight out of the water, right? And go up 9.1 meters. Can you guys see that okay? A little bit. Right? But then, separate question, if a dolphin launches at 45 degrees, right, then what will its maximum height be and some other things, right? What they failed to be clear about is that the dolphin is launching at the same speed in both of these cases. So the speed at which it launches at 45 degrees, this V naught right here, is the same V naught that it has when it launches straight up. And that's, I kept looking at the problem going, well, you didn't give me, so like I was deep into like some pretty fancy physics to try and work back the initial speed based on various parameters. And I finally was like, this can't possibly be a physics 2A problem. And it wasn't even, it was like way harder than the physics 4A problem. And I was like, no, something's not right here. And I looked it up. And like, they just assumed that everybody would understand what they were talking about, right? So this is a two-part problem. You do a part here, okay, where you find the initial speed for a dolphin that launches straight up, okay? So we don't know what the initial speed is. What's the final speed if it launches straight up? When it gets to max, it gets to a max height of 9.1, what's its speed? 0, right? V final y, V naught y, okay? Do we know AY? Negative 9.8, because this is a free fall problem, squared. Do we know how long it was in the air? Nope, okay. Do we know the vertical displacement? Plus 9.1, y plus? It went up, okay? And we don't know anything about the x, right? Okay, so how do we find the initial speed here? Like, what's the strategy? Big hint. So we're looking for V naught y. What do we not want to have in our equation? T, because we don't know t, right? So which equation fits the bill that doesn't have a t in it? Third one. Oh, what's that, Mr. Balogh? I haven't eaten in 12 hours, so I'm not. V naught y squared plus 2ay delta y, or not delta for you guys, just y. All right, so can we find our initial speed out of this? Yes, okay. And then once you get this number, you will then use it as the initial velocity for the real problem, where it launches at 45 degrees. And then it's like the golfer and the soccer player and all that kind of stuff. So I apologize. There was a cute picture of a dolphin, and I was like, oh, this will be a fun problem. They should have added a sentence, right? Or just broke it up into two parts. Find the initial speed of the dolphin. Part B, now assume the dolphin leaves the water at the same speed at 45 degrees, right? Like that would have just been clearer, but they didn't do that.
Maybe in the world where one of them is constantly.
Maybe. Physicists.
That's a 2AY, right?
2a sub y. Yes, Mr. Balogh's handwriting strikes again. Plus 2a sub y, y times a y. Yeah, I'm very messy. Okay, so I apologize for the dolphin. It's still kind of it's a good problem actually. It's just they should have worded it better. All right, in the last little bit I have before we're going to end class early, I want to do an exercise that I know will help you do about 5% better on average on your exam. This has been shown scientifically, not just statistically, but scientifically, to work. And so I want to take you through a little bit of a mental exercise on how to improve your score, specifically on physics tests. Okay, and this actually has very little to do with physics and everything with how your brain works. I don't know if you guys noticed, but I do a lot about like brain function in here, don't I? Okay, and full disclosure, I have been hacking your brains the entire time. So it's time for me to come clean. I have been manipulating you to get your best performance out. I don't think manipulation necessarily means bad or evil, although that tends to be the connotation we use for it. But has anybody caught my manipulations now that I've told you that they're there? Okay. Do you notice that about once every 10 to 15 minutes, I get really distracted? Like I'll shout or scream or start talking about something that seems to be not related or semi-related, or I'll tell a joke, or I'll throw something stupid up on the screen. You need to know that there are no wasted minutes in my class. What's the average adult attention span?
5 to 10.
It's 10 to 15 minutes. It's going down a little bit, but generally it's 10 to 15 minutes, okay? Which means after 10 to 15 minutes on a task, your brain needs what? A break. It needs to change gears, okay? What am I doing when I do something silly, or I say what's going on over there, or I do something weird on the screen, or whatever? I take your mind away from physics for like 30 seconds to a minute or two, right? And then all of a sudden I say, what are we doing? Let's get back to the physics. What have I just done? I reset your brain. I took your attention and I reset it so that I can get another 10 minutes. There's like a half-life as this goes by. I got to do it more and more towards the end. Okay, because your brain just gets full. It gets full in the first 10 minutes, right? Physics is a lot. But I've been manipulating your brains and your attention span, not your attention span, but I've been working within the average attention span, right? To try to help your brain clear the psychological air to be able to then reconcentrate on the task at hand. So let me give you, this isn't a hack, okay? This isn't something I'm going to do. This is something you're going to do to help your brain during the exam. And in order to do it, I have to make you very uncomfortable for about 3 minutes, okay? I'm actually going to shut off the recordings, right, for this one. For those of you that are catching this on YouTube without being in class, you can go look up stereotype threat if you want to learn more. But I'm going to shut off the recordings here. Got to get my backup and this one. Bye, YouTube.